Welcome to the next session of Meet the Oracle Masters, the online series. This time with my favorite Oracle Master of the day. We just established that, Jeff Smith, Product Manager for Database Tools. If you have any questions, please type them into the questions and answers box so I can interrupt Jeff as we go along. If you have any questions at the end of the presentation, there's probably some time left for that too. So without further ado, I'll hand over to you, Jeff.
Thanks. Just share my screen. All right, so some information already on this first page. Point your phone to that QR code and get yourself a few hundred dollars or euros equivalent credits on the Oracle Cloud if you want, if you haven't done that yet. Also, on the next screen or two, I'm going to have a link to a Oracle Live Lab that Brian, my coworker, put together that demonstrates a lot of the material that I'm going to share in today's session. I noticed a fellow Oracle community member, Jim Saprinsky, is having a similar session in June that's focused on the autonomous JSON database. My session today is just for Oracle databases in general. Obviously, what I'm going to talk about today will work great and run extremely fast without any management required in autonomous, but also what I'm showing today you can do in any 19C or higher on-premises Oracle instance, standard edition, or when XE is updated for 21C, you can also do it there. So let me just get on to our show. I'm going to do a little bit of live demo today. I have a lot of material, so I'm going to be doing more slides than live demo, but as our gracious host volunteered me, I'm happy to take questions as we go, so you can put those in the Q&A, and we'll make the session as much guided by you folks as you want it to. So here is a preview of that live lab. If you're not familiar with the live lab ecosystem, we used to put these hands-on kind of self-paced tutorials on our VirtualBox VMs, and that was a big thing to download, although I still use my VBox, and we still update those. So if you're looking for an Oracle database that you can spin up on your machine and be your own DBA, the VBox images are nice. But for folks wanting to learn concepts and not necessarily have to have the infrastructure running on their own machine, we've built a nice Apex application. It's available at livelabs.oracle.com, and it's got material across the whole spectrum of Oracle database. I'm going to be talking about REST and REST APIs for your Oracle database in my next session here. There'll be a lab for that. This is the JSON Adventure Lab, which shows how to take a JSON document and import it as a relational table, or importing it into a JSON document store. So you can use SQL, or you can use the SOTA query by example filters against the information in those documents or tables. So it includes sample data, includes all of the code. You can simply copy and paste it into your interface, and the interface is going to be your browser, because the nice thing about these labs is it's integrated with the Oracle Cloud. So you can borrow one of our tenancies, which, basically we foot the bill and you get access to an instance for like an hour or two while you run the lab. But then once that's over, that goes away. Or you can click the link to go start up your own always free tenancy. And that's going to be yours forever. The only caveat to the forever is if you stop using the database in those instances for more than a few days, we shut down or suspend the database. And so if you come back a month later, it'll still be there, but you might have to wait a bit for it to get kicked out of the archives. All right, so enough marketing. Let's get into the tech. So This session is based off a popular book series, or at least it was popular when I was a kid. It was Choose Your Own Adventure. And if you went the wrong way, the monster would eat you. And if you went the right way, you would find the treasure. There was like 100 variations of that. Our adventure today is based off of, you have some data structured as a JSON document, and you're going to put it in an Oracle database. You have a couple of different ways you can go. The only difference with our adventure book is regardless of which way you choose, you're going to get the treasure. You don't have to worry about ending up consumed by the bad guy. So the two paths, there's actually a third path that's kind of a permutation of the two, or a hybrid. But the two paths are, you can get your data into a relational structured table, columns, rows, pure SQL interface. And at that point, it's no longer really recognizable as a JSON document, although you can use SQL queries and functions to bring the data back out as a JSON document. Nothing wrong with those things. But once it's in the database in that sort of format, any relational database user, any Oracle person from the last 20, 30, even 40 years is going to be able to recognize and work with that just like they always have. The other route you can go is you can turn the Oracle database into a JSON document store. So if you go look at the NoSQL or the Not Only SQL crowd, they love this idea of being able to have the schema of sorts defined in real time based on what's in a particular JSON document. So it's extremely flexible. You can add attributes as needed. Each document or each record you could think of, they don't have to look the same. And they very nicely support arrays and objects. So you can see in this screenshot here, I have nested things. So I have this attribute called statistics, and underneath that I have something called delays, and then I have attributes with delays, but then I also have something called weather codes, which is an array, so I can have just as many items in that as I want. So a lot of JSON documents you look at are quite boring and just flat. The more interesting ones will look more like this weather delay pattern, which is the example data that you'll see in the lab. And I think there's about 4,000 of those records. I think, unfortunately, they're very much biased towards North America. So I'm sure there's a similar data set for European air travel. Yeah. So I'm assuming everyone's seen a JSON document before. If not, this is like the pretty version of a JSON document. JSON's popular because pretty much every programming interface and platform out there is fluent and has APIs and functions available to work with JSON. It's not just a thing for JavaScript anymore. And from what I can tell, it's pretty much won the war with XML. I don't see a lot of new projects starting up today where they go with XML, but of course we have tons and tons of, I won't say legacy, that's always mean sounding, I think, but we have tons and tons of applications still running in XML, and the Oracle database, of course, has a complete XML solution as well. I'm going to, I think, give these slides to the hosts of our session today so you can come download them later. I think they're also on my SlideShare. If you go to my blog, thatjeffsmith.com, and scroll back a few days, you can find my JSON document adventure slides there. But if you pay attention to these numbers, these are actually the slide numbers, or at least they were before I did some updates this morning. We're going to talk about the SQL stuff first. But here again is just a quick overview of why people enjoy working with JSON. It's a little easier to read than XML sometimes just because it's not as fat, I guess. It doesn't have that HTML kind of tagging structure. You kind of just get straight into the data. But the schema flexibility part is the key thing. So for example, if you're a insurance company and you need to quickly create a new policy to cover some very esoteric or edge case event, you're able to update your model just by on the fly adding a new attribute to these document structures. Whereas in a relational database, you'd have to crack open your data model, open a table, update the database. As a database person, I'm fine with that. That's been my life for years, but I understand for some people that's not flexible enough. So they enjoy this JSON stuff. The key story today is the Oracle database has this converged model where you get to have the best of both worlds. So you can use an Oracle relational database to store these JSON documents. You get full access to the to the SQL library, all of the Oracle database features like analytics, like the ability to do joins, all of the statistical machine learning, fancy stuff you've heard us talk about over the last 5 years. But really the main thing here is ACID transactions. So consistency, durability, performance, it's all there. So the data is always going to be updated in real time. You're not going to have queries showing you some data at one point and different data at another point. And there's if anything, you really do get the best of everything. There's no sacrifice in terms of performance. If anything, if you look at some benchmarks, we're actually faster than Mongo, especially for OLTP transactions. And the security bits are all there as well. So you're not having to bolt on and add these things to other JSON or NoSQL database implementations. It's all in the Oracle stuff. So we've just extended the Oracle stack to support JSON in addition to the other things. These additions started popping up in 12c. They really matured in 19c. So when I said earlier, you just need a 19c instance, that's the in our tools that we've developed, that's the minimum version where we give you this sort of full experience you're going to see on the upcoming slides. You don't have to be on the 21c. You don't have to be in the autonomous JSON database to use this stuff. So in the converged model, we have a single database engine that can handle all of these workload and data type requirements. You don't have to spin up individual databases for each bit of your microservice implementation. You can just have one instance that covers everything, or you could also have multiple Oracle instances that are tuned to cover specific workloads. So the Oracle Autonomous Data Warehouse, that's a service offering of an Oracle database that's been tuned explicitly for a data warehouse workload. The JSON database service has been specifically tuned to give you the very best performance when working with JSON. But you could take any Oracle instance and kick it up and use any of these features in any of ththese workloads. You might just change some init parameters and deploy some different API deployments for these specific instances. So when we say converged, it's not some magical unicorn that works fast in all instances of it, but it's the same underlying engine that can serve all of these workloads. You might just tune the instance parameters for specific things. Or you can just go with the transaction processing general workload and get pretty good out of the box. It's just some nice things you get in our JSON implementation in the Oracle database. There's a set of APIs, there's a set of functions, there's a set of data types that make working with the JSON data very easy. So if you want to put a JSON document inside of an existing Oracle table, up until 21c, you would say, I've got a varchar2, a clob, or a blob. And I'm going to put the document inside of that, and you're going to use a constraint that tells the database there's JSON data in there. In 21c, there's a native JSON data type. And so that's the table, the relational story, and then you can use SQL across that. In the JSON document store story, we have these things like data guides that are basically data dictionaries that we give you that tell you, what's in your JSON collection. Since they're not strongly typed and defined in the data dictionary, like you can't do a describe on a JSON document. You can't query user tab calls to see what's in there. The data guide gives you that feature set. So it's good for building indexes, and it's good for getting an idea of what's in your collection. And then all the ACID stuff. Indexing support is there. So again, there's no, you're not sacrificing features that the normal Oracle database will give you just because you're using the JSON document store interface. So you can create views against your documents, and then actually use SQL across those views and treat the basically use the views to treat those JSON document collections as tables. Anything in the collections can be indexed, and you can have several different types of indexes. So if you need quick, efficient access to some buried nested attribute inside of one of these documents, that's pretty easy. I'll show you how to do that. Joins aren't a problem, because joins aren't a problem in Oracle. And no need for custom code. So we give you APIs and drivers to use all of this stuff. All right, so let's talk about taking a JSON document that someone's given you, and you just want to throw it into the database real quick so you can use SQL against it. In database actions, or SQL Developer Web, which is our browser-based tool, which runs out of ORDs. Once you're connected, you can simply on the worksheet page say import data and point to an Avro file or a JSON file or even an XML file and say import this to a new or existing table. So what we assume in your JSON file is that you have an array of JSON documents, and then we just treat those documents as rows, and then the attributes inside of those array item documents are treated as columns. And then if you have a JSON document inside of the JSON document, or if you have an object inside of those arrays, those columns will come in as JSON documents still. So this is kind of like that best of both worlds thing. I've got a JSON document that's coming in as a table, but then it's not flattened completely. Like this time column actually has a JSON document inside of that. Also, so does the statistics table. If it was one of those boring flat JSON docs where it's just one level of attributes, it would come in as a pure table implementation. So this database actions, or the SQL Developer Web, that's available in a couple different places. It's there out of the box in the Oracle Cloud with any of the autonomous services, but it's also available anywhere that you're running Oracle REST data services or ORDs. So a lot of people know ORDs because it's this web gateway for the database, and they use it for hosting Application Express or Apex apps. But that's not its only use case. And obviously Apex is not a requirement for running ORDs. So if you want to build RESTful web services or REST APIs for your data or for your databases, then ORDs is the way to go for that. It's free, it's included with the database. It runs in your mid-tier. And one of the options you have when you go to install time is to make SQL Developer Web available. So this just gives you the database desktop tooling available inside your browser. So the worksheet allows you to do the same things the worksheet would do in the desktop tools. The keyboard shortcuts are the same. The look and feel we tried to keep as consistent as possible, although it's made to look nice in a browser where that makes sense. And there's a button, or you can right click on an existing table and you can just say upload. And these are the formats that it supports. So here's a mostly flat JSON table coming in. So there is an array here. This starring attribute has an array in it. Everything else is at one level. And when I do the import, this is how it comes in. The starring column would still have be defined as a JSON column, although at the most simple type of JSON column, where it's actually just this array of values. That's still valid though. And in the lab, as you're running through this, this is the sample data that you'll see, and we'll give you the queries that you can use to explore this once it's in. The more interesting way to go is when you've got nested items with or without arrays. And so you can import this document and you still get a table, but inside that table, you're going to have columns defined as JSON. And when you bring that into the database, you got a couple of different options. So I've said this before, varchar2, clob, and blob are your routes to go for 19C and lower. I've got blob there in the Oracle red color. That is the preferred way to go. That's what the JSON team recommends for the best performance. And if you ask them, why is blob better than clob? It's because with the blobs, or the binary large objects, there is no character set transformation happening between the database and the clients and the drivers. So the data is streamed immediately back to the client. That's going to be faster than CLOB or varchar2s. In 21C, and going forward, there's a native JSON type, which is basically got all the benefits of blob plus a bunch more. And you don't have to worry about the constraints anymore. You simply just type the column as JSON and everything else is taken care of at that point.
Yep, I got a question. If I'm starting out with the JSONs in the 19C and below versions, and I'm upgrading to 21C or above, will there be some sort of conversion tool available, or do I have to do that myself?
I don't think there's a conversion tool.
Yet.
And I wouldn't make that. Well, I mean, there's what the database gives you out of the box, right?
Yeah.
So there's there are the packages that you can use to rebuild tables. There's obviously the alter table, column, data type. So that's the better question, I think. And I'm not sure on the answer. I think the answer is yes, but I'll have to confirm this. Can you on the fly say alter table, column, change this from a blob with that constraint over to native JSON type? You know what? I'm going to ping my JSON friends on the corporate Slack, and I'll maybe have an answer before the end of the session. Can I in 21C say alter table, change column? Okay. So here's what the table with that airport delay data would look like. There's like 3 flat columns, ID, airport code, and name. And then there are 2 of the more interesting columns that have those JSON documents inside of them. So when using SQL against these, some of it's pretty straightforward. Obviously, you're just querying the columns. When you want to go into the more interesting columns, like for example, time or statistics, the database team tried to make it as easy as possible. So there's this dot notation, the statistics column dot the attribute name. And since the attribute is got a space in it, then you've got to quote it. Then dot carrier. And I'm going to show this as minutes delayed. Then back in my query, when this comes out, I've got the name of the airport and the sum of all of these through the table over here shown as minutes delayed. So the dot notation is probably the easiest way to get started on using SQL to query JSON structured data in your tables. It gets a little bit more complicated than this, as you can imagine. We have our JSON value function. So I can bring the data back out of the database as a JSON document itself. Here's another type of this dot notation. This $sign is sort of like a pattern matching. So it's the equivalent of the wildcard in the JSON parser engine. They were looking for a character that could serve the places like an asterisk that wasn't already taken, and they ended up with the US $sign. So if you're curious of why it's that, which is interesting because a lot of the developers are based in Europe, so why didn't they choose the euro? Who knows? Here's some more SQL fun. So I've got this JSON table going against the time column, and I'm saying pull out attributes from that time JSON document as columns. So the raw data, it looks like JSON, bracket, month in quotes, :9. So that's September, I would guess. Yep. And then using this function, it comes back out as what looks like a relational table. So when you start creating views on these things, you can make this extremely easy for all of your database users and consumers. They don't even have to know under the covers this is all being stored as JSON documents, either complete and whole, like for the entire data set, or even just pieces of the rows. So you can make it extremely easy to work. They don't even have to learn this stuff if you create the views over these things. Here's another example where the arrays get interesting. So the arrays could have many objects in them. Asterisk in array says everything in it, but I can also do things like 0, 1, which says give me just the first 2 items in the array. So here I'm getting back the first 2 types of planes involved in these delays, which doesn't probably make sense unless, of course, these are for some reason some sort of implied ordering, or you're just previewing a screen and saying, hey, just give me the first couple of rows in this array so the user has an idea of what's in there. But this is the type of notation you could do to say, hey, and for these models, just give me the first 2 items, so 0, 1. I could have a 3 in there and it would just give me the 4th item. All right, so that's the end of our table stuff. And if you go look at Beta Hammerschmidt's blog on Oracle Blogs, he's got tons and tons of posts of how to effectively use these JSON functions. And obviously our friend Tim Hall, aka Oracle Base, has you completely covered in his JSON section as well. So if you're a child of the 80s like me, you remember when Doc Brown took us to the future and said, hey, where we're going, we don't need roads, and then he made the DeLorean fly. Well, I'm saying with the JSON document store, we don't really need tables. And I'm going to show you how you can interact with your JSON data without worrying about tables. Although under the covers, Oracle is still storing all of this stuff in a table for you. So SOTA is the acronym. You know, we wouldn't be Oracle if we didn't bring in new acronyms all of the time. The Simple Oracle Document Access. It's basically a Mongo or a NoSQL type of interface for your data. So you're able to manage collections. So sort of think of collection as a table. A collection is a group of documents, and think of a document as a row in that table. So a document is one complete entity. So where the interesting part is one JSON document could have 30,000 nested JSON documents in it. So your one row kind of could have 30,000 sub rows. When I bring those in, I generally split them out as individual ones, but you're going to have some data modeling here. You can't avoid data modeling just because you're using JSON. JSON gives you flexibility, but you still got to have some sort of logic implied, or you're going to pay some heavy tax later when you need to bring things together and get things to work. Once you've figured out how you want to store the data, we have plenty of different types of interfaces and drivers to start using with that. The easiest one to use is probably the REST APIs, because then you have nothing to install. So wherever you can make HTTP calls, which is pretty much in any programming language, or if you're in a command prompt, you can use things like curl. You just simply say, hey, go get me this collection, or go put this collection into, or put this document into a collection, or delete this document from a collection. You're just making HTTP calls. Those are provided by words, and that's called SOTA for REST. But if you're a Java programmer, or if you're JavaScript, if you're Python, we have native drivers for you with all the connectivity bits required to start working. Some of those will require an Oracle client as well. There is a pure command line interface. So if you use SQLCL, which is sort of our modern SQL+, there's a set of SOTA commands in there. So from the command prompt, you can say create a collection, add a document, and query my collections. Database Actions is our web interface. So that's SQL Developer Web. That's the new name for SQL Developer Web. All of these are an abstraction over top the Oracle database. So at the end of the day, you got an Oracle database, you've got a schema, and you've got tables in that database, and your documents are going into those tables. But instead of running SQL and create table and add in, that kind of stuff against that, you're using the SOTA API to interact with your data. So you're making pure JSON document calls, and under the covers, Oracle's translating that to the SQL engine. So if you go and look in your schema where you've created these collections, you'll have tables by the same name. It's just in those tables, you'll have 1 or 3 columns, like an ID, and then like a single column for the entire document. So if you want to start getting data out of your collections, you need to be able to start saying the types of things that you're used to saying with SQL. We use JSON to describe the JSON that we want back out. So the Oracle nerds, the internal people, the people in the know, they'll often just call this QBE, another acronym. That's query by example. So you're saying, here's a JSON document that describes the JSON that I want back out. So you can use this for filtering, and you can use it for ordering, and you can also use it for searches. And you're not going to be typing this stuff from scratch. Your drivers and your APIs are going to do a good bit of this for you. I'm going to be showing the query interface that we have built into SQL Developer Web. Well, you will be typing some of this, although we give you a lot of help. But on the right, where I've got this JSON document with movie ID 109410 with a start time that's greater than or equal to, and also less than, and then ordering it by screen ID start time. In my collection, I could have, I don't know why I would have this, but in my collection, I could have 50 movies of the same ID, and it would just pull out those, and then they would be ordered by screen ID and also by start time. And then down below, there's a spatial implementation of JSON called GeoJSON. You can say, hey, let me just find the documents that are within 5 miles of these coordinates. Yeah, so here's what this would look like in your Java application using our JDBC driver. I'm not a Java person, so I'm not going to go too much into this. Here's the interface we built into SQLCL. So there's a SOTA command, and instead of saying create table, you would say, what do you say? I think you just say SOTA create. No, not SOTA create. Brain fart. It's like SOTA create to create a collection. But then instead of saying select star from all tables, you say SOTA lists, and that shows you all of the collections. Then start getting things out of the collections. You do a get on the collection name, and then with various flags after that. So the default would be to bring you out everything, but then you could also say, no, only the documents that match these specific criteria. So here's an example. SOTA find, I created a collection called Pop as a play on soda, because in the US, you know, Coca-Cola, some people call it soda, some people call it pop, some people call it soda pop. But I'm saying look for in this collection anything that starts with T. In this text column starts with T. It's not anything, sorry. Find an attribute called text, and that value starts with the character T. So that's why this one popped up. I'm not going to tell you all what SQLCL is because I'm sure you already know, but just in case you forgot, it's also from our team. It's a very lightweight tool. It's like the best of SQL Developer and SQL Plus married together, and it's got a bunch of new modern things built into it, and it's also easy to get access to. So as of last week, you can download this directly from oracle.com without even signing into the website and agreeing to the end user license agreement. So it is totally completely free and easy to get now, and we'll be doing that for our other database tools shortly. If you're in the Oracle Cloud and you open up Cloud Shell, SQLCL is already there. And if you're anywhere else, SQLCL should be in the public yum repo, so you can just say yum install SQLCL. SOTA for REST. So if you're building an application and you just want to make HTTP calls, these are the types of calls that you can make to manage your collections and your documents and their contents. So I could delete one thing in a collection. I could delete an entire collection. I can get things out of my collection. I can make updates. I can insert things, and obviously I can do my gets. So as you're building your web apps, or building your mobile apps, or building your automated curl bash scripts, you would just make these calls and you have instant access to your data. We use those to build the web interfaces that I'm going to show in a second. For me, this is my favorite SOTA for REST call. So in a single call, I'm saying, hey, to this existing airport delays collection. I'm basically doing a bulk insert to that collection. I'm feeding it a single JSON file. This is a 7 meg file that has those 4,000 nested JSON docs in it. And when I send this in like 2 seconds, it was able to insert those as separate docs in the collection. And when I go and look in the table behind the collection, these are a few of the columns that you have. If I pull up SQL Developer Web in Autonomous or in my on-prem install, and I go and click on the JSON page, you get a JSON interface. So this is not where I'm typing SQL. This is where I'm using the JSON SOTA features to interact with my data. So I can create new collections, I can query collections, I can update items in the collections, I can download them, I can diagram the collections, which is kind of nice. I can do all kinds of things. So basically, we've put a single page web app in your browser, and we're using that SOTA for REST API to build this stuff, which I will happily give a full demo of. Let's do that now. So I've already got a collection here called Untapped JSON, and this is my beer diary. And I've used one of these QBEs or one of these filters to say, hey, just show me the beers that I've logged where the beer itself is brewed in the country of the Netherlands. And these are those items. I think most of these are Heineken, but this one's not. I'm not going to try to pronounce this one. But Patrick, do you want to tell me what this is called?
De Koningshoeve.
See, you got a lot closer than I did. So this interface would be useful for a developer, I think, if you're debugging or just needing to do data cleanup in the database. I don't think you're going to be spending a lot of time doing QBEs in this worksheet interface. I mean, most of your time working with your JSON data, you're going to be in your app, running your app, doing app things. But when you do need to get into the database and start doing database level things, then these tools are here for that. Or if you're looking for that SQL-like experience, except for SOTA, then that's this. So I can replace this document. If I click this button, it'll browse my local file system for JSON or text files, and I can upload it. And if I need to export it, then I can click this button and it brings it down. But these are all fully editable. So celebratory beer after 5 hours of yard work. 5. I am slow. So save. And it's updated. Oh, collection has no version. Oops. So I've done something that's not allowed, but it's protected my data using the rules of the road. If I need to create a new collection from scratch, the only thing you need to provide is a name, and everything else is optional. But for example, I could say in this collection table, I'm connected to a 19C database here. So these are the data types available. And I can even be specific about what I want to call that column. And I can say how strict I want to be on how good the JSON structure is. Lax is basically like if I'm doing really stupid things in the JSON doc and it's not technically JSON, it'll still let it in. Standard or strict is it better be pretty in terms of JSON, or it's not going to pass that check and it's going to be rejected when you try to do the insert. And you got all kinds of other things in here, but for 9 out of 10 people, when they come in, all they need to provide is the collection name. So it's over here on the right. When I click on it, it's completely empty. I can do an upload. So this is going to be a single record. Helps if you pick a good file. Oops, JSON, let's try that one. Okay. So when I was saying earlier, some of these documents that you bring in might be a bunch of other documents. That's this case. The way I probably would want to store this, I mean, from my perspective, is I would bring in each of these as separate documents. And that's totally an option if you want to do that. I was talking about how we have these tools like the data guide that kind of give you an overview of what's in your JSON docs or your collections. So this is an interesting data set. This is actually my Twitter personal data that I've extracted. And it's quite nice how they organize all of this. You know, so I can see who I mentioned in my tweets, and I get access to all the links that I shared in tweets, including the images and media. I mean, I could do a query right now to see how many times I mentioned Patrick. Actually, maybe we should try that. Nothing like live demo to screw up. So control spacebar brings up insight. And then I can start coming in here and pulling out different attributes. So in here, this. Patrick, what's your Twitter handle?
Patch 72. PATCH.
Yeah, patch 72. Is that it?
Yep.
All right, let's see if I'm right. No, it's not quite right. You're right. I did not pick the right. So curly brackets like this is select star. Let me pull up one of these. Oh, it's screen name, I think. I needed to do screen name. So, yep. Yep. So here are all of my tweets where I've mentioned Patrick. Hopefully some of them are nice.
We go way back.
I know it's sad. So here I'm saying, here I'm saying to Patrick, all I know is what Google is telling me. I'm ignorant when it comes to Dutch dialects, but I tried. So I was using Google Translate or something. So this is actually really, really useful to me because I've got 110,000 tweets and I'm looking for stuff. I can't find it. And Twitter has APIs that you could use, but I've said, hey, Twitter, just give me all my tweets. I've thrown in an Oracle database and I know how to use SQL and I know how to use this soda stuff. So it's really easy for me to find, you know, anytime I've tweeted about beer or mentioned Patrick or both of those things, it's quite nice. So I'm vain. I've also done things like, hey, show me any tweet that I tweeted that I got at least a retweet count of 50, and then order that by the tweet ID. And I'm telling the database, hey, tweet ID is a number. So tweet IDs in this JSON doc are stored as strings. So you have to give the database a little bit of a heads up of what kind of data it's working with. So when I run the query now, I can find all my tweets that have been retweeted at least 50 times. And I am ordering it by the ID. I could also order it by count. So this tweet's 69 times. I think I've broken this record, but I did this data dump like a year and a half ago. So this isn't the the most up-to-date version of this set. When I say that this JSON is flexible, here is a diagram, sort of like an ERD of sorts. It's hard to see on one screen, but here's how the tweets are structured. So these are objects. Inside these objects are other objects or arrays, and they're blown out here. So we're kind of showing this as tables with links, but all of this information is in a single document. That's why people love NoSQL, because they think, oh, I don't have to write joins anymore. And of course, joins are the devil because joins slow things down. Whereas in the real world, we know joins don't slow things down. If anything, sometimes they speed things up because the database knows the data is related. Well, I don't think we're ever going to win that war, so we're just like, said, screw it. We'll give you what you want. So here is that flexible JSON doc inside an Oracle table. So I wanted to show this too. This feature is not live yet, but it's coming later this summer. When I say this adventure, you get to, pick any which way you want to go and you win either way. Even if you store your things as JSON, and even if you're using the SOTA query by example filtering APIs, you can still use SQL against that, because remember, we're storing it as a table. So in the interface, we have the SQL button, and we show you the SQL that you would need to run this same query. So I'm going against that tweet table, and I'm saying where JSON exists, JSON document. JSON document is the column in that table storing the JSON document. Here's that $ dot notation that we showed earlier in the beginning of the session. And here in this order by, we're saying, hey, order this by, we're telling the database, hey, this is a number. And you can see when we run these queries, we're grabbing the first 100 rows. And then as you scroll through those, we grab more. So when I ran this, here is the relational table view of that data. Inside of this is the actual blob, which I'm not going to show you right now because it wouldn't make any sense. It's too big. Let's see. So what did I miss? Yeah. So this view below is sort of like the rows that come back from your query. It's a preview. These documents can be quite big. I think the average document that we see is anywhere from like 5 to 20K, but there's no limit. They're stored as blobs or JSON at the end of the day. So they could be gigabytes or even stupid things like, terabytes. When you double click on a record and we open up that side panel, that's then the entire document that's being shown. I showed you the insight help. So control spacebar, we bring up all of those predicate functions, descriptors that you can use. So we make it really easy to build these filters. So I start with greater than, and then I feed that the column or the attribute that I want it applied to. So in this case, only show me documents where more than 40 flights were canceled. And I don't have to know the structure of the document. It actually brings up all of the objects, arrays, and items in there, and even tells me what the types are, how it's typed in the JSON. Sometimes like Twitter quotes everything. So everything shows as a string. If it's actually being stored as a number, it'll tell me it's a number, and it'll tell me I don't need to actually quote the number in the pattern. So that's nice. This is the new feature that's going to come in our next update in cloud and Words on-prem. So it'll just be the SQL button. We'll show you the actual SQL. That'll be nice. This will also be a good way to see if the indexes you've created are actually working, because once you have the SQL, it's really easy to do an execution plan. We'll also have a view for you coming soon, where we actually let you pick and choose the items inside the document. And then we turn that into the relational view. So again, it makes the database people in your org, makes it really easy for them to query it out. They don't have to learn any of this new JSON stuff. They can just use their basic SQL. And then here's querying that view. Again, the user has no way of knowing that's not a regular table unless they went and used like the SQL text expansion trick to see the SQL under the view. But the columns in this view are defined using these JSON patterns. So I do recommend, if you're going to work with JSON in Oracle database, that you learn or at least recognize these patterns. And really, the more you use it, the easier and easier it gets. It took me a while to get the gist, especially when the arrays come in the different levels of nesting, but it's really not that bad. And we're also going to have a dialog to create and manage your indexes for you as well. So again, here's my JSON document. Here's everything in it. You pick the attributes that you want in your index. And there's like 3 or 4 different types of indexes that we'll support. And after those indexes have created, once you click on one, surprise, surprise, we show you the attributes of that index as a JSON document itself. So the indexing, if you're running these filters and you're noticing that it takes too long to run, it's just like an Oracle table. With the indexes in place, you're getting access to the data much, much quicker. And in an autonomous, eventually what you'll get in the JSON side is the automatic indexing feature will be applied there as well. So you don't even have to worry about the indexing. Okay. If you want a more like low level exactly how the JSON engine works in the database, and you also want to know how the autonomous JSON database works with the JSON native type, go see this second link here. And one of our developers on the JSON team, Josh, did a session on this. It's like 45 minutes, and it's quite good. I think that's all I got. Were there any other questions?
No, there are no questions at this moment. Maybe people are still thinking about them, so we'll give them a minute.
I give them a minute, then I've got a hard stop to my next magic show. So over on the Ask Tom office hours, I'm doing a session with Brian on SQL Developer, the next generation, which is just an overview of SQL Developer Web, which is this. So it's a lot more than just the JSON interface. Like, it's got a full-blown REST IDE built into it. You can manage database users, create ones, expire their passwords. It's got Perf Hub and SQL Monitor built into it. You can edit tables, create new ones with the dialogues. This is the future of SQL Developer. The desktop app isn't going anywhere, but this is what we're going to be focusing on going forward, and eventually it probably will replace the desktop app. So if you're interested in learning more about that, head over to Ask Tom on the Oracle, go to the office hours, and we're starting in like 2 minutes. Actually, I have to run, or Brian's going to get nervous, mad at me. So thanks for having me. I'll see you guys soon, where I'll be covering the REST stuff.
Okay, thanks, Jeff, and I'll see you next week.
Yeah, cheers. Bye.
And that concludes the session of today. Hope to see you next week again.